Good morning, honors science students. It's a happy Thursday morning for you. I want you in your notes, I want you to look at yesterday's notes, the ones that you took on the periodic table and getting information out of the periodic table. And what I want you to do is a very quick activity. Take no more than 3 or 4 minutes on this. I repeat, no more than 3 or 4 minutes. Here are the instructions. I'm starting right here in this blue text, having your favorite friend or a relative in mind, and using beryllium. Okay, we're looking at this square right here, beryllium, atomic number of 4, atomic mass of 9.012. What I want you to do is, again, you've got your favorite friend or a relative in mind. Define what the information is found in each square of the periodic table, using beryllium as a guide. Then describe to that person how to determine the number of protons, neutrons, and electrons in beryllium. I'm going to pause the video right here, and you should probably pause it also. Take 3 or 4 minutes, no more than that, and then restart the video, and we'll be talking about a new subject at that point. All right, I'm back, and now I'm going to talk about isotopes. And we've got 4 learning targets for isotopes. I believe that they are listed in today's agenda, so I don't know that you necessarily need to write them down. If you feel like writing them down, you certainly may. I can identify that the number of protons identifies an element. I can determine the number of neutrons in an isotope of an atom. And I can read isotopic notation, and I can write isotopic notation. And if I was to talk about this in terms of an essential question, there it is. Why are isotopes not really all that complicated? Because they're not. Because, there it is. I see 2 huge words there. Neutrons, mass. Isotopes are only about neutrons and mass. That's all you really have to understand. That's the big, huge picture. Isotopes are about neutrons and mass. Okay, so now the first bullet point, that's your definition. And again, remember, when you're taking notes, you should be trying to develop ways to take abbreviations in notes, and abbreviations that you'll understand. So anyways, isotopes are atoms of the same element that have different numbers of neutrons. Okay, well, you know what? The simplest in the universe, the simplest isotopes are isotopes of hydrogen. There are 3 isotopes of hydrogen. There's one isotope that has 0 neutrons. There's a second isotope that has 1 neutron. There's a third isotope that has 2 neutrons. Oh, and if we change the number of neutrons, look at the second bullet point. Neutrons have mass, don't they? So when you change the number of neutrons, the mass number changes also. Now, the chemical properties of isotopes are pretty much identical, but some of the physical properties will be different. Now, one of the things that happens when you change the number of neutrons in the nucleus is it might make the nucleus a little bit more unstable, and that might lead to some radioactive particles being released by the nucleus, and they could decay. And so some isotopes are radioactive. They're used as tracers in research and medicine. Nuclear power plants are driven by certain isotopes. Nuclear bombs are also driven by certain isotopes. So, but in general, your basic isotope will have identical chemical properties as every other isotope. Some of the physical properties might be a little bit different, and a lot of it is related to the fact that you get unstable nuclei when you mess around with the number of neutrons in an atom. And so now I'm going to spend some time talking about an analogy. Just like cars have different models, atoms have different models, and guess what they're called? Yes, they are called isotopes. So there is the Lamona. That is a type of car. And the Lamona, instead of being 3 different isotopes, has 3 different models. There's the Lamona G. There's the Lamona GX, and of course, the Lamona GXL. Now, when you look at each one of these, they all have different options. So you can read through the different options It's very important in Minnesota to have those heated seats in the wintertime. But it doesn't matter the options that you get. What matters is that they're all Lamona. So it's that particular shape, that lemon shape, that makes them all Lamonas. Yes, you can have different models, but they're all a Lamona. Now what we're going to do is put the Lamonas over there. You've got your different models of cars, and now we have our different isotopes. So we're going to talk about 3 different isotopes of carbon. There's carbon-12. So carbon-12, well, all carbon in the universe has 6 protons, and then the 12 is the mass number for that particular isotope. So carbon-12 will have 6 protons and 6 neutrons. Carbon-13 will have 6 protons and 7 neutrons. And finally, the third isotope of carbon, carbon-14, has 6 protons and 8 neutrons. So what you see there, where you see carbon-12, that's one way to write an isotope. And all you have to do is write out the name, and then you write the mass number. And another way, and actually so please notice the circled protons. 6. Every carbon in the whole entire universe, no matter what isotope it is, they will all have 6 protons. The thing that makes isotopes is a differing number of neutrons. Here's a second way to write isotopic notation. You can talk about the specific isotope carbon-12 by writing it this way, carbon with a 12, or you can write it sort of like what you have in the periodic table in each one of the cells, except you just have to flip-flop the mass number and the atomic number. Okay, so basically that's it on the Lamona, which is different models of cars and different models of atoms, and those are just simply called isotopes. Now, here are 3 bullet points for you. The last one is probably going to be the most important because there's going to be a test question based on that. So the atomic mass of an element listed on the periodic table is the average mass of the mixture of its isotopes. Hey, guess what? Something like 99% of carbon is carbon-12. Something like 1% is carbon-13, and a very small fraction is carbon-14. When you mix them all together in those relative abundances, the average mass is going to turn out to be 12.01. That's what you should see on your best friend. Your periodic table should show a mass of about 12.01. And I'm going to show you how to do that mathematically, how to calculate that 12.01 in a little bit of time. So now, the atomic mass is the average mass of the mixture of the isotopes. And then the atomic mass is an average mass of the element's isotopes because most elements have more than one isotope. But let's now look at the third bullet point. There's a test question that you'll see that is pretty much related to this. It's going to ask you, okay, take phosphorus, for instance. There's an isotope phosphorus 37, there's phosphorus 29, and then there's phosphorus 31. Which of those is most abundant? And so basically you find which one of those is closest to the average atomic mass. And so that's a rule of thumb, by the way, that third bullet point. It's just a rule of thumb. It doesn't always work, but please remember it for the test. If you're not understanding isotopes by now, it doesn't get any simpler than this. These are the 3 different isotopes of hydrogen. Notice that each one of those isotopes has 1 proton. Yeah, the blue dots are protons, so protium has 1 proton. Deuterium and tritium both have 1 proton. Notice that the only difference is the number of neutrons, 0, 1, and 2. I can't make isotopes any simpler than that. If you're confused by isotopes, have a look at this picture and just understand that an isotope is just something that has a different number of neutrons. There are 3 isotopes right here. Each one of those has a different number of neutrons. Okay, here are your official notes on how to write isotopic formulas. The first one at the top we've seen a couple slides ago, These are your official notes on it. What you do is you write the symbol, and then the mass number goes up higher, and then the atomic number goes lower. The other way to write it is write the chemical name, and then the mass number. And by the way, when you just write carbon-14, everybody knows that all carbon has 6 protons, so you don't really talk about that, and it's not really necessary. This is just a shorter version than maybe this, because here you have to write out the whole name. And now, okay, I think that is everything except for we are going to look at an example on how we get the average atomic mass. So here are your notes. To calculate average atomic mass, so when you look at the periodic table and you see that hydrogen is 1.0008, how did we get that mass? Carbon is 12.01. Oxygen is 15.99. How do we get those exact numbers? Well, here's how we do it. So you multiply each isotope's atomic mass by its percent abundance. You have to take the percent and make it a decimal percentage. So take 99.2% and turn it into 0.992. Then what you do is you add the results of each of the multiplication together and round off to the number of significant digits we tell you to round to on the test. It's probably going to be something like 2 decimal points. So now here's the example. Okay, carbon. And this is typically what you're going to be given. You're going to be given the percentage and then the mass for each of the different isotopes. And what you do is you multiply, and then you multiply, and then you add together. Boom, you're done. So basically, you take 0.9890%, turn it into a decimal, like this one right here, multiply it by that mass. Well, 12 is 12, and you get 11.87. Then 1.1%, express that as a decimal, 0.0110, and then multiply it by 13. You get 0.14, add the two numbers together, and there you go. Now, some of you, I'm going to tell you a mistake that many of you make. My hope is that you don't make that mistake. So what some of you will do is you'll take 12.01, and then you're going to divide by 2. Don't do that. It's not in your notes to do that. You're thinking, well, I've got my 2 points here, and when I get an average, and when I'm adding these things together, and I've got 2 things I got to divide by 2. No, you don't. Because guess what? When you take that 0.98 and that 1.10, and you turn them into decimal percentages, you've kind of done that. You've divided by 100 by doing that. You know, percent, it's out of 100. So please do not add another mathematical step in here, because the 2 steps are simply these: multiply and then add. All right, that would be it for the day. I'm going to see you all tomorrow, Friday. So have a great day. Make sure you get everything done. Make sure you get that self-assessment done today, and see you Friday.